Okay, so today from the id of ed, I have the stepper drive control box kind of coming along here. It's the wiring looks like a mess, and what I have is 3D printed front and back case and some sheet metal parts to tie it all together, a sheet metal cabinet, and gotten as far as some test wiring here to this would be the plug that would go to ultimately to the stepper, to the control of the calculator. And then, like I said, I got to clean up all this wiring and so forth. Kind of dubious wiring color coding here too. But at the moment, what I have is a couple different indicators, direction, various different modes and so forth. I'll have the calculator be able to just do everything itself, or have this machine, this box, basically run the motor totally manually. So right now what I have it set is if I hold this button down, the stepper motor will do a full rev each time until I release the button. And as long as I hold the button down, it'll just keep revving, and then when I release the button, it'll eventually come to its basically its home location. And so right now I'm trying to figure out is do I have the calculation for the RPM indication correct? And I got to clean up things like some of these decimals don't flush out. Right now I think it's set for 37 RPM. So it should be about 37 RPM. And then it turns out this is of course an audio taper pot and not a linear pot. So the potentiometer on this guy is, I'll have to find a different one. This button's a bit hard to push. So that would have been about 50 RPM. And I think this is I think that's about 100 RPM there. And then the max speed before the stepper stalls is about 245 RPM, it looks like, if I have that all calibrated right. And one way I could probably, the thing is, in order to count and know that I'm actually going, say, 60 RPM, I could just have it spin for 1 minute and I can count 60 RPMs. And when you do it down around 30 RPM, you can keep up and count it pretty well, but it's kind of hard to count when you start getting up to these bigger numbers. So I happen to have a machine that's able to count counts very nicely, and that's the mechanical calculator itself. So I think what I might do to solve my problem, to confirm that my RPMs are indeed what I think they are, is I think I can actually I'm up to the point where I can hook the motor up and then set the program code to spin the motor for whatever I think the RPM is for 1 minute, should be, and then I can push my button and then the motor will spin for 1 minute at what I think the RPM is, and I should be able to just look at the counter on the calculator number cycles, and that should give me the confirmation. Because like I say, if I've gone from about the lowest right now, I have the scale factor set to is 37. So I've been able to count like 37 up to about 50 pretty reliably, and it sure looks like I got it right. But there's nothing quite like being able to go at the range that it's more likely to go at, which is about 200 RPM. The belt drive on this guy is going to be about a 2-to-1 ratio, and that'll get me around the 300 RPM that I think the mechanical calculator is expecting. So I think what I'm going to do next is hook this, mount the motor back up, and just see this thing spin the calculator and see what happens. So give that a try next. And that is a very noisy fan in there. I happen to have a 24 volt fan, and it's 24 volt power supply, and of course I just had to put a fan in there. It probably isn't really necessary, and it's a pretty old school American made stepper control module there, and a Arduino single board embedded computer is what that all is. So that's kind of it. So next scene hopefully will be a calculator running on a stepper motor. Okay, so I had the calculator up and running with the stepper control module the day before, and it seemed to run very nicely. You know, it took relatively little to tune in the location of the control switch and everything, and it seemed to run pretty nicely. Some minor compromises in spring tension and so forth, and I still got to sort that out. But then I came in the next day and, you know, to do some more work, and every once in a while the stepper motor would take off on its own just for an instance, very randomly. And my conclusion was that this old cloth insulation had a lot of crud on it, and you could put a multimeter on it and you could just see a bit of resistance, and it looks like I can still see a little, maybe a little something there. I ultrasonically cleaned this, and hopefully that is gone enough. But I might have to redo this wire insulation. It looks like I can still measure something every once in a while. See if I can get something again here. I had something for just a moment there. The plastic looks pretty good. You know, many years of the switch sparking and so forth. Probably put down a little bit of a fine film of metal, conductive metal, and maybe oil and dust. I had something for a moment there. I can't seem to find it again. I'm hoping that this will work okay. The switch itself is amazingly simple. It's just a couple early pieces of plastic with you know, these guys just kind of clip in there. Let's see if I can put those guys back in. They just kind of held in by a couple little plastic features, just like that. It's certainly not UL listed. This switch is, you know, you get in there and you touch it, you're going to see 120 AC line voltage, and it's the contacts themselves are just insulated from grounding to the rest of the chassis by a little piece of plastic tubing that they put over the roller that ultimately makes contact with one of these contacts, and then they're just sandwiched back together with this plastic part and this one screw, which I believe one of these mounts the thing to the calculator, and the other one holds this guy together. And I guess I'll have to go to the calculator to remember which one this even is. I think it's this one, but it's just a nut that's held in the plastic, and that is it. And then I have 3D printed some a little guard or a cover here for putting the contacts in, and then I got myself I ran out of round ring loop connectors, so I got these guys and some heat shrink because it's fairly light wire, obviously, and I didn't want to break it. And then that goes to a simple little header plug I have on the back of the control box, and that's basically it. And then this guy clips into place. Couldn't be simpler than that. And it's really odd is the calculator, when I got it, you know, it had these ring lug connectors that connected the switch to the there's a current limiting resistor and a capacitor, and then the motor itself with its governor, and that's it. And these guys look like they're from the factory. And the other side of the same sort of ring lug connectors, they're an interesting design I've never seen before. They look like they're maybe just they look suspiciously like rivets that grommets you would use for like on a fabric, even like a denim fabric or a canvas bag or something like that, or you'd want an eye loop to loop lacing through or something like that. And maybe that's what these really are, and maybe they're not from the factory, but they're on both the motor resistor side and on this side, and these were just being insulated by just some old electrical tape that was really stiff. And so I thought, at least for the moment, I'd preserve this arrangement with a simple little 3D printed part. I guess I'll maybe post that on Thingiverse. Obviously, you know, AC line voltage, you probably don't want to use, you know, simple 3D printed parts. In this case, I'm just using logic level. If I do go back to AC, the AC motor on this guy, I'll probably do a proper solder crimp job or something like that, or at least wire nuts, something like that, and I'll abandon their ring lug connectors. But for the moment, I just live with this. If indeed this cloth is still too conductive, then I'll just obviously have to undo the solder joints and put new modern wire on here. But I guess I'll go put this all together and put this on the calculator and see what we get. Okay, so I got the wires all hooked back up. You can see it's just a ring lug screw connection, and the idea is that these connectors just kind of stuff into these little plastic slots here. If I can get this guy in, I might print a longer version of this guy. There you go, simple as that. And then these fingers. The plastic's a little on the stiff side, but it clips in there, I think, pretty decently. And so, you know, somewhat reasonably safe. So, anyhow, there we go. Okay, so we have the motor control switch back in place here, and I must say, if you want to get anything done on these things, various let's see, I guess they're called they call them forceps. I can't remember what these little guys are called. They're very nice little precision little instruments, and you can get into the various spots here without hopefully losing too much sanity. And like I say, these calculator guys, they must have had incredible patience. That took quite a while to get that in, and it would have been just too painful to look at online real time. The thing I'm kind of running into now is I've had to adjust this spring down here that I adjusted really early in this whole calculator series, and I've had to adjust it again a bit. And I think I got the switch set to work pretty well. I might have a little noise in the system too, so I've put in a little bit of a debounce in there. But now I've kind of labeled my modes and so forth, and I guess I could kind of go through those. This switch I've yet to program yet. It'll eventually give me, once I write some more code, some various modes to run the stepper motor set amounts of time and trace back the amount of time it might have moved previously, and that might help me in the future to sort out some other stuff. It might not wind up being used even especially on this calculator, because I'm already getting fairly close to possibly getting it running. Speed control for the stepper motor, right now I have it set at about 200 RPM, I'm thinking, on the motor. I do have a belt ratio of 2:1, and then I'm still debating what the gear ratio is on the planetary. And just looking at it, I think I'm still running lower than the RPM, which at least is mentioned in the much earlier calculator videos. So I'm not really calculator manuals of about 400 RPM. I think I'm lower than that. Just looking at some other YouTube videos and so forth, I'm guessing I got the right value. This button here, or knob here, will operate the force that the stepper motor will go at. Right now it got dialed to its normal value here. I could tweak it up a little bit further with changing a potential, a resistor in here. But it's basically set so that I can make the stepper motor weaker in case I'm in a condition where I'm concerned about the stepper motor damaging the calculator. Although so far it looks like the calculator is far more robust than what the motor can probably generate anyways in the way of power. Some of the modes in this control box are actually just directly wired, like the forward reverse. Right now I have it, it doesn't go through this the processor and any programming. It's just a physical pin. It's actually being pulled high or low with a switch here. And being that this is a calculator is always going to go in just one direction, I figured there's really no point in having the software do anything with it or the processor. But if for some reason I want to reverse it, I can reverse it. Enable is to enable the stepper motor on or off in itself, and that's kind of handy for if I want to figure out the, for instance, the switch on the calculator right now. For instance, instantly enough, this divide stop will actually close the switch on the calculator, which I'm not really sure exactly how divide stop's supposed to work if you're actually triggering manually the stepper, the normal calculator motor on. It seems a kind of a mystery, because all it is a piece of metal strap that then lifts up on the arm that closes the switch. So it's kind of a mystery as to how that's supposed to work. But anyways, when I was adjusting the calculator normal switch here, it's kind of handy to have that light up and then not have the motor actually move. So that's what that's about. And then once I get a little bit fancier in the controls, this switch will be enabled to have it so that only the calculator can control the motor, or it can switch it to this mode and only this box will control it. Right now I can move the motor, which you can probably hear. Maybe you can see the arm, the crank is still on there, flapping in the back there. I think you can just see it back there. I could switch it to that mode later on, and then anything I do on this button and maybe other modes will control it regardless of what the situation of the switch is, although it might record the value. It's a lot of feature-itis that probably won't get used, because I'm already fairly close to probably getting this calculator running, so this box is probably questionable whether or not it'll get used a whole lot here, but I'm hoping to use it for other projects. Maybe other calculators might need this stepper treatment until I get it all worked out. So anyhow, I think I'm to the point where, kind of like my previous demo, the calculator is up and running now under motor control, and I can probably just demo some simple controls with just now it being run by a stepper motor rather than my hand cranking it. So I guess what I'll do is I'll add some numbers, and I think that's lower speed than normally is. I could speed it up more than that, but let's see. I've set that to repeat, so I've set that now to not repeat for addition. So the R repeat button is off, and it should clear that entry each time, and it did. Okay, so that's pretty good. And let's see here, can you guys see those numbers pretty well without? Never, it's always the thing about this stuff. You never get quite enough light. It looks like those other dials are kind of poorly illuminated here. See if I can get this a little better. Not really happy with that. I don't know what to do on lighting. I'm going to have to get better on this whole camera photography stuff. Just seems like those guys aren't well illuminated. Now they're illuminated, but they're kind of glared out. I think that's probably as good as I'm going to get. Okay, right about there. So we can clear the upper dial, or lower dial, upper dial. I can add numbers just fine. I can add more numbers, and I can subtract numbers, and then I can clear everybody just fine, and I'll set it to repeat, and I'll do some multiplication here. Put that on register, and then I'm going to I guess I'll multiply this number by I don't know, a few numbers here. I'll go 5. Okay, and then I'll move the carriage over 1, and I'll go 2, and I'm going to assume that number is correct. So far it looks like it's actually doing a pretty good job here. Get these guys out of the way so we don't know what order numbers are here. I still got to get this case screwed down and cleaned a little nicer and see if clear works. So it looks like I'm up to the functionality I had my previous demo of the calculator with just hand cranking. I was showing multiplication, and just its general functionality is kind of restored. Now the next thing I'd like to show is, I'll just get the control box out of the way because he's really not the star of the show, is he? By the way, I hope to get this control box, all the components listed on Thingiverse. I've got to get the cover on it and so forth, but so that other people want to print this case and fold the sheet metal and so forth, those files will hopefully be on sometime in the near future. We'll kind of keep up with the this channel. Maybe I'll eventually get those out. So the next thing is I'll still be able to see the display. I think you can see it pretty good. The next thing I've been trying to get to work is this divide tab, and I think I probably babbled on earlier that the spring tension on this spring that I had troubles with early on, that I had to mess with, I think might be causing me trouble. But this control pin lever here that works on that arm that has those 3 notches I showed earlier, this spring force isn't quite enough to put it in there all the way when I hit the tab. Otherwise the divide tab seems to work. What I have to do is I have to give it a little help, and then it moves over, and I'll probably bump into my control box. Ooh, just misses it. Okay, and it works very nicely. Okay, so let's get that out of the way here. Professional lighting. It's people spend big bucks for people who know professional lighting, right? Okay, so I think those numbers are somewhat displayable. So my biggest thing is I got to figure that out. That's kind of my next thing here. Otherwise, I can now, let's see here, not quite there. Something else is wrong. There we go. Okay, so it didn't quite return the other direction, and I don't know if that's because I don't have enough spring force or too little spring force, but that's kind of the next thing to figure out. Otherwise, it works pretty nice. So there it is under stepper control. I think I'm lower speed than I normally am. I guess I'll max it out for the moment and just see what I can get here. So that's the fastest the stepper can go, which is about 245 RPM. If I go any higher than that, it'll start to lose steps. You'll overdrive the stepper faster than it can physically move, and it'll stall out on you, basically. So that all looks pretty good there. So I guess I'll go over and I'll hit repeat, and I'll do I'll multiply something here, I guess. And I'll just keep adding stuff. It's one of those things you have to kind of know what you're doing here. After a while, you get kind of confused. These calculators, you really do have to kind of pay attention to what you're doing, especially with the semi-automatic. So it all seems to work. I'll hit clear, and I think I'm not overdriving it. I think that's still a lower speed. That's the fastest that my stepper motor can go. I was kind of hoping it'd be able to go a little faster than that, but that looks like that's my max RPM, which at least I know for sure is probably 245 RPM at the motor. What it really is at the output of the planetary, I'm still a bit uncertain on this. It looks like I'm still probably lower than what I think this thing is. In other words, I don't think I'm overspeeding this guy. At least doesn't seem to be unhappy with it anyways. So the next thing to thrash out is the divide tab, and probably won't get it done today, but